Okay, good afternoon everyone, and thanks for attending in this presentation. I'm talking about the tree detection in orchards from very high resolution satellite images using the scale space theory. I'm a PhD researcher at the University of Twente and working with Alfred Stein. He's the professor of spatial statistics. In traditional agricultural management, field was the smallest unit, but nowadays in precision agriculture management, if we consider the orchards as a field, the individual trees are much more interesting, and even the individual leaves. So the precision irrigation as a specific form of the precision agriculture concerns about the saving the water, energy, and money, and it's also considered the optimal management strategies for efficient decision makers for farmers and the decision makers. And in this aspect, the remote sensing technologies can help us in the precision irrigation. So the challenges are here, the environmentally, the efficient use of the water, and scientifically is the detecting the tree crown boundaries. For example, if we consider the crop water requirement for each of the individual trees, so the crop coefficient is one of the function of the crop water requirement. So in this aspect, the tree types are really important, and also the tree cover fractions. As you know, that remote sensing images can be grouped in the coarser and finer spatial resolutions. In the coarser spatial resolution, we may observe the individual trees, but in the different spatial patterns, so we cannot really detect them specifically. So in this study, we considered two orchards. The first one is peach, and the second one is the walnut. So the study area is located in Qazvin province in northwest of Iran. So in this image, we use the two kinds of remote sensing images, WorldView 2 that we applied our method, and the UltraCam digital aerial images that you can see the red polygons are derived reference tree crown boundaries. So as I mentioned, the remote sensing images in the coarse resolution, they are inappropriate to detect the tree crown boundaries. In the finer resolution, there are not sufficient information for spectral and geometrical properties of the trees. And in very high resolution satellite images, if we have the adjacent tree canopies interlocks, especially in the growing season, so we cannot properly detect the individual trees. There are several image processing techniques for detecting or delineating the tree crown boundaries. The region-based image segmentation that consider the group of pixel as a one object. The template matching, which is not appropriate if we have the orchards, in our case, with different tree sizes. And the valley following, which considers the local minima pixels surrounding the tree crowns, which is good for the edge detection. And an early example is with the local maxima. They study that the trees and their backgrounds with the similar contrast that they have problem with this local maxima technique. So we propose the scale space theory to detect the individual trees from very high resolution satellite images, especially on the complicated orchards with the tree sizes in different tree sizes. And the questions are coming that how to use the results to investigate the application of the scale space theory and how to validate the results. So this is the framework of our study for the tree detection. On the right hand side you can see the world view 2 with the panchromatic images at with panchromatic image at 50 centimeter and multispectral bands at 2 meter spatial resolution. For the first orchard, as you can see, this is the histogram of the first orchard. We can observe with the dashed blue line the non-tree and the tree on this histogram. So we directly use the panchromatic band to apply the scale space theory. And for the second orchard, which is the walnut, we have a very complex spatial pattern. So, and because of also due to the sun illumination and shadows, we use the NDVI image, and here is the histogram of the panchromatic image of the second orchard, and this is the histogram of the NDVI image for the second orchard. And as you can see, we have the trees and non-trees on this image. And then we applied the scale space theory for blob detection. And on the left-hand side, we have the UltraCam aerial photo. As I earlier mentioned, that we derived manually the polygon of each, the three crown boundaries as a polygon to do the uncertainty assessment. So the scale space theory is originally proposed by Lindenberg, the professor in Stockholm. And the L is here is the scale space representation, which is equal to the convolution between the input image as a function of f and the Gaussian kernel. So if we consider the scale of 0, then the scale space representation is equal to our original image. Here in the bottom, you can see there are three trees, and along this yellow line, we just illustrate the intensity of the trees, and here are local maximums and local minimums of this intensity. And the trees are normally in the remote sensing images, they have the bell-shaped the intensity profile. And the gray level blobs are the regions, as they consider the group of the pixel as the polygon of the tree, and they are the pair of the local maximum and local minimum. So as you can see in this image, we have the gray level blobs at different scales, from 0 to any scale, from the finer scale to the coarser scale. So for linking those gray level blobs to actually bring the higher order object as an individual tree, so there are several blob detectors. So we use the determinant of the Hessian for the scale space representation. So the local maximum in the scale space can be considered with as a point, different points with the x, y as a position and s as a scale along the three directions. Those three directions in the determinant in the Hessian matrix are the x, y, and s. and we have the maximum of each them, and then we applied the interpolation between those points. And the size of the blobs is actually in the relation, is with the relation of the scale. So, but how does really a scale space work? Because we can have the zero scale to any kind of scales. So basically in the original image, as you can see, this is the very small subset of the trees in the NDVI image of the second OR card. You can see there are lots of noises, and if we increase the scale, for example, to 50, we are going to somehow remove the noise, but maybe we miss also the trees. So in this study is really important to how to treat the scale levels from the minimum scale to maximum scale. So we consider the minimum scale as a minimum diameter of each trees in both OR cards, and also the maximum scale as a maximum diameter of the trees in the OR cards. So here is the table that you can see the minimum diameter for the first OR card and the second OR card. They are different in size, and the size of the trees can be visually also extract from the images. So for the uncertainty assessment of these individual tree detections, we use the object accuracy indicator with true positives, which are in our criteria, they are truly acceptable, and type 1 and type 2 errors as a false positive and false negatives. And total detection errors with the overestimation and underestimation. As you can see, here is our blob from the scale space theory, and here is the tree crown boundary from the reference data. And this gray area is acceptable in our criteria. And also positional accuracy is the distance, the difference distance between the center of each polygons. Here is the result of our method on the first OR card, which is the pitch. And out of the 519 individual trees, 498 trees are detected as a blobs, but also only the 468, about 90% of them are truly accepted in our criteria. And the false positive and false negatives are somehow close to each other with 5.5% and 9%. And the overestimation and the underestimation is they are the slightly different between those kind of errors, and the total error is 0.49, and the positional accuracy is the 0.24, which is less than the pixel size of the panchromatic image of the World View 2. And in the right hand side you can see the error map, or the green one are truly acceptable, and the false positives and false negatives. And the left side is the blobs from the scale space theory. And this is the result of the second OR card. And out of the 500 individual trees, about 408 of them are truly accepted in our criteria. And the false positive and false negatives are the same. And also the overestimation and underestimation. But also the positional accuracy comparing to the first OR card is more. And here also you can see the error map of the second OR card. So in this work, we are really considered the way which is really a straightforward for automatic tree detection. this is as a kind of unsupervised work, but you can also, supervised, but you can also consider it as an unsupervised. So with the considering the minimum size of the tree to the maximum size of the tree, because in our algorithm you can also run it first and consider and get the results with the minimum size and maximum size, and then you can also run it again, which brings one more step pre-processing. So the controlling the scale variation is really important in this study. And as I mentioned earlier, if the scale increases, so we miss some the information. So it's really important to how to treat the scales. And the benefit of this work from the traditional image analysis is that we have the less user contribution, which is also the key contribution of this work. And this method also applied on very high resolution satellite image like world view too. Nowadays the UAVs are much more interested. You can also apply it on other kind of the images. So for the importance of the tree detection, the results can be used for the integration with the crop health, crop water requirement, and monitoring the trees. And one more issue is about the shape of the blobs, because they are as a circle, and as you know, the trees are with the irregular shape. So this is one of the issues that brings the overestimation and underestimation in this study. And the last point in the discussion is that, for example, if you have the different fields in the agriculture area, especially in the growing season, if you have the orchards, maybe next to the orchards could be the patch of the wheat, as you can see in this image. So how can we be sure that our method can really detect the trees truly? As I mentioned, the trees on the remote sensing images, they have the bell-shaped the intensity profile, which can really help us to detect the trees on the remote sensing images. So in this study, we actually find the meaningful delineation of the individual trees. The study area is in the Qazvin as a semi-arid region with the traditional irrigation network. And this area is really important in Iran because the agricultural product of the Tehran is about more than 70% of that kind of products are coming from this region. And in this way, the scale space theory provides the automatic way for the tree detection. And in this way, we can say that this is really at the edge of the modern remote sensing to detect the individual trees in the orchards with the three different sizes, different spatial variation, and also with the limited prior information. And the results also are in good agreement as we compare them with the reference data. But also the further improvements are needed for the saddle points, which are the local minima, to prevent the multiple detection of the same trees, which brings the false positive errors. And the flexibility of this modeling can be used for the scientists, farmers, and decision makers. And thanks for your attention.
Thank you.